Hi guys, so welcome to my YouTube channel. So in this video I'm gonna teach you about the Doppler's effect. Okay, I know most of you students may heard about the Doppler's effect. So in this chapter I teach you the common equations of Doppler effects with different instances. Okay, so first we're gonna talk about the common equation of Doppler effect actually. Okay, uh, think. Okay, so I'm gonna draw a sound source. Okay, imagine this is the sound source. Okay, it have a velocity of us. Okay, just think. Okay, then it emits a sound of frequency f naught. Okay, then this sound will go like this, and here our observer. Okay, so imagine that this observer has velocity towards the direction of the source, and then we know. So the velocity of light, velocity of sound is, imagine, v. Okay, so what's about the Doppler's effect? Doppler's effect means the variation of frequency. Okay, the variation of frequency, this is the original frequency emitted by the source. Variation of this frequency which is heard by an observer. Okay, this is the observer, due to the relative motion of the observer. Okay guys, okay, let's go to the direct equation then. So you guys remember that if we write the apparent frequency as f, then we can write the common equation for Doppler's effect as f equal v plus o minus v naught divided by v plus o minus vs into f naught. So guys, this is the general equation of the Doppler's effect. So if we name this, this gonna be the real frequency. Okay, real frequency. This gonna be the velocity. Okay, not relative, velocity of the source. Okay, so this v is the velocity of sound. This v is the velocity of observer. So you guys easy to practice that when this division present. It means the observer is in the top and the velocity of the source is in the down. Okay, so this whole part, this part, we can see the relative velocity of the observer, and this part we can see the relative velocity of the source. Okay, then this is the general general Doppler's effect equation. Okay, guys. So let's move on to the other chapter. That means the applications of Doppler's effect. Means the applications of Doppler's effect. Okay, guys. Okay. So first we're gonna take the instances the both the source and the observer are coming towards each other. So both the source and the observer are coming towards each other. So it means like this, the source, and this come into this direction with us velocity, and this having f naught frequency. Okay, this emits sound like this wave, and the velocity of the sound is gonna be v. So this is the observer, and he's gonna have velocity towards this direction, that is u naught. Okay, this f means the apparent frequency that heard to this observer due to the Doppler's effect. Okay, then like in this instance, we can write the Doppler's equation as how as the general equation. We're gonna draw like f equal v. So this observer is also have relative velocity towards this direction. Now, therefore, I told you guys that always observer in the top of the division. Okay, that's easy to remember actually. So we can write the relative motion of the observer due to this direction. It relatively add with this sound direction to get the relative motion. Okay, then this u naught, and guys, and we're gonna we want to take the relative velocity of the source. Okay, then this is the special point you actually want to remember. Okay, so this source actually has velocity towards the velocity as same as the sound velocity. You have this velocity also this direction, sound velocity also this direction. Then the velocity relative to sound velocity is v minus us. Okay. Then we're gonna multiply this with f naught, means the real frequency. So from this we can get the apparent frequency heard by the observer when the source and the observer moves towards each other. Okay. Guys, so let's move to the second instance. So in the second instance, take that both of the observer and the source are moved apart from each other. Okay, moved not towards each other, apart from each other. Okay, so we can take this as this is source. If this is the source and has a velocity towards outer direction, has us and has velocity f naught, it emits sound wave like this towards this direction with a v speed, and the observer is in this. Okay, he also moved to away from the source. Okay, so the apparent frequency heard by the observer is f. So we're gonna find this f. Okay, guys. Okay, so I know that you already taken the value. So it's happened like the general formula: f, the apparent frequency, equal relative velocity of the observer. Okay, the top of the division is the observer. So relative velocity of the observer relative to this velocity of sound in air. Okay, so you guys see that these two velocities are the same direction. That means we want to subtract this velocity with the observer velocity. Okay, then you guys saying that the source velocity is going to this direction, the sound velocity goes to this direction, then we want to what? To get the relative motion. So yeah, we want to add this. Okay, add this, then we gonna multiply it by real frequency. Okay, this is the second instance. This is the instance where the source and the observer moves away from each other. Okay, guys. Okay, let's move to another third instance. Okay, so in this instance, both the source and the observer moving into same direction. Okay, moving into same direction. So if we consider this as the source and it has velocity towards this direction, us. Okay, it has real frequency f naught. Then it emits sound wave like this towards the observer direction, it has v velocity. Then we have our observer in this direction. He also have velocity towards this direction. Okay, not. Apparent frequency heard by the observer is f. Okay. Then I know you guys know already the formula. So this gonna be apparent frequency f equal the velocity of the observer relative to the air. So velocity of the observer means velocity towards the station as same as the air. Therefore we want to do what? We want to subtract this. Then yeah guys, also the source velocity direction also this towards this direction, and the air direction also towards this. Then we want to subtract this. Okay, and multiplied by the real frequency. So this is the Doppler's frequency that heard by the man when both source and man get to same direction. Okay, let's guys. Okay, then another fourth. I think fourth. We gonna take the source coming towards the stationary observer. Okay, source coming towards the stationary observer. Okay guys, this gonna be the source, this gonna be the source, and this coming towards us. It emits sound wave like this towards this direction as v. Velocity of the sound wave is v, and here our observer here is stationary. This means velocity 0. Okay, so we're gonna find the relative velocity held by this observer. So it's a little bit different, but not too much. Okay, too much. So you know already the apparent frequency f then equal, if we say the real frequency f naught, this equal to relative velocity of the observer relative to the air. Okay, then this has 0, this sound velocity has v. Then what's the relative velocity? Relative velocity is v. Then we're gonna take the relative velocity of the source relative to the air. Then air is towards this direction, this source towards the same direction. Therefore we're gonna subtract us, then multiplied by f naught. So this the apparent frequency when the observer in stationary and the source moves towards the observer. Okay guys, so sorry guys. So let's talk about some different another one. Okay. So I hope you guys now you already have some knowledge about this. So I'm gonna take another slide and it's some different one to you. Okay. So okay, let me think. Okay, this the source. Okay, this the source. This emit sound wave. This is source. If not, frequency sound wave emit like this. This V, and here our observer. He's have apparent frequency F. So what I'm gonna change is the direction of the moving velocity. This moves, imagine that this moves theta angle towards US to the this velocity of air, and he is moving this direction with the beta angle, and we know okay it's somewhat difficult but not too much actually. So how to find this? Okay, let me teach you. So F means the apparent frequency equal what velocity of first we write velocity of observer relative to the velocity of uh, air. Okay, so if we subject this angle, and I'm gonna take this velocity towards this direction. Okay, then we have v naught cos beta towards horizontally towards the source direction. Okay, then I'm gonna get this also towards this, and it will make US cos theta towards this direction. Okay, then it's done actually. Then we have to take the relative motion of the observer relative to the air. So air v plus, because they are in opposite direction, plus v naught cos beta, and then divide by velocity of source relative to the sound emitting direction. So velocity of source means towards same direction, both are towards same direction. Then we're gonna do what? We're gonna subtract them. Subtract v s cos theta. Then we're gonna multiply this by f naught. So that's done. Okay, that's done. So So in this video, I'm gonna talk about the Doppler's effect and its applications. Okay, so if you learn something from that, please subscribe my YouTube channel and share with your friends. So hope you guys enjoyed the video. So thank you very much.